welcome to Sleep to Science. Tonight we're exploring the incredible secrets hidden within that faint, cloudy band stretching across our night sky. When you glance up at what most people dismiss as cosmic decoration, you're actually seeing something far more extraordinary than anyone realizes. What if that modest ribbon of light represents a colossal stellar metropolis containing over 100 billion residents? A structure so enormous that light takes 100,000 years to cross from one side to the other. Here's what's fascinating. Our entire solar system occupies nothing more than a quiet suburban address within this galactic giant. At its heart lurks a supermassive black hole that outweighs our Sun by 4 million to 1. This magnificent stellar carousel has been rotating as a unified structure for over 13 billion years. Every star you've ever wished upon, they're all passengers on the longest cosmic ride in existence. We'll trace how astronomers discovered this stellar metropolis hiding in plain sight. We'll explore why our remote galactic address represents the universe's most fortunate accident. And we'll see how this cosmic neighborhood spins through space like the ultimate carnival ride. So settle in. Before we begin, leave a quick note in the comments where you're listening from or one thought you're carrying tonight. I read them, and they genuinely help shape future journeys. If you'd like more nights like this, subscribe, only if you enjoy these late-night journeys. Now let's begin. Ancient civilizations looked up and saw spilled milk from the gods. They named that ghostly river of light the Milky Way. For thousands of years, nobody suspected this delicate band harbored the universe's most extraordinary secret. The terrifying truth began revealing itself in 1609. Galileo aimed his primitive telescope at this streak of light. What appeared as smooth, milky radiance exploded into countless individual points of blazing fire. Each speck represented an entire star, many of them stellar giants that dwarf our sun like monsters compared to fireflies. As telescopes grew more powerful, astronomers realized something shocking. They weren't looking at distant decorations sprinkled across empty space. They were seeing the interior anatomy of an enormous gravitational predator. We live trapped within something far more extraordinary and terrifying than anyone had imagined. The numbers become genuinely mind-bending. That innocuous band of light harbors approximately 100 billion stars. Each one burns as a nuclear furnace with the power of millions of hydrogen bombs detonating every single second. If you attempted to count these stellar residents at 1 per second without stopping, you'd need over 3,000 years to finish the job. Every cosmic fire burns hot enough to vaporize any material that ventures too close. Yet gravity holds them all in perfect formation. We're not looking out at scattered celestial objects. We're seeing the interior view of our own cosmic predator. How would you feel if you discovered your home address was actually in the cosmic equivalent of witness protection? Our solar system finds itself banished to what astronomers politely call the galactic suburbs. We live roughly 26,000 light years from the galaxy's blazing downtown core. Our neighborhood sits in something called the Orion Spur. It sounds impressive until you realize the truth. This minor spiral arm serves as little more than a cosmic side street, a stellar backwater connecting two of the galaxy's major highway systems. This suburban exile creates astronomy's most profound illusion. When you gaze at that cloudy river of stars stretching across dark skies, you're seeing billions of distant stellar neighbors, all embedded within the flat, rotating disk of our galactic monster. The Milky Way appears as a glowing band because we're trapped inside it. Picture riding on the surface of an enormous cosmic record player. You're looking edge-on through the galactic plane at fellow passengers. But our modest location represents the universe's most fortunate accident. Stars packed into the galaxy's downtown region endure neighborhoods so dense that deadly radiation would sterilize nearby planets within moments. The central supermassive black hole weighs as much as 4 million suns. It regularly triggers catastrophic stellar explosions that turn the core into a cosmic killing field. Our peaceful suburban exile provides something remarkable: relative safety from the galaxy's most violent neighborhoods. We traded spectacular fireworks for stable tranquility. This cosmic banishment places us in the galactic habitable zone, far enough from chaos to avoid instant annihilation, yet close enough to benefit from heavy elements forged by generations of exploding stars. Right now, you're rocketing through space at 140 miles per second. That's fast enough to circle Earth's equator in just 30 minutes. Yet you feel absolutely nothing. We're all passengers on the universe's most incredible carousel ride. Most people live their entire lives without realizing they're aboard this cosmic merry-go-round. This galactic carousel has been spinning for 13 billion years. The ride stretches 100,000 light-years from edge to edge. But size isn't what makes it extraordinary. The physics-defying way this rotation operates challenges our everyday understanding of spinning objects. Picture a record player spinning at different speeds across its surface. That's impossible, right? The center always spins faster than the outer edge on any normal rotating object. But our galaxy laughs at these rules completely. Stars near the galactic center whip around at 500 miles per second. Out here in cosmic suburbia, we cruise at a more leisurely 140 miles per second. Yet somehow we keep pace with the inner regions. One complete orbit around this cosmic track takes us 225 million years. This represents one galactic year. Since Earth formed, we've only completed about 20 trips around this massive circuit. Dinosaurs lived and died during just one galactic year. All of human history fits into a tiny fraction of our current lap. Every full rotation spans entire geological eras. Mountains rise and fall. Species evolve and vanish. Ice ages come and go like brief seasonal changes. We're riding the universe's most patient Ferris wheel. Stars maintain nearly identical speeds regardless of distance from center. This impossible behavior revealed a profound astronomical mystery. It changed everything we thought we knew about our cosmic neighborhood. Imagine trying to map a massive apartment complex while trapped inside a windowless room. Dense fog blocks every possible view outside. That's exactly our situation when mapping our galactic home. We spent centuries playing cosmic detective with extremely limited visibility. Advanced technology finally cleared the cosmic fog in the 1990s. Our galaxy has been concealing major architectural features that completely escaped Earth-based detection. Something enormous remained hidden until recently. We live inside what astronomers call a barred spiral galaxy. A massive stellar highway stretches directly across its central region. This cosmic interstate system has dominated our galaxy's design for billions of years. Earth-based observers had no way to detect it. The galactic bar consists of billions of ancient stars. They form an elongated structure 27,000 light-years long. That's longer than our entire distance to the galactic center. This cosmic highway connects central regions to the outer spiral arms. Gas and stars flow inward along this structure like rush hour traffic. Everything eventually feeds this supermassive black hole anchoring our galactic neighborhood. Why couldn't we spot this massive feature for centuries? Our sideways perspective makes detection nearly impossible. Cosmic dust clouds block most visible light throughout the galactic disk. They create what astronomers call the zone of avoidance. Only infrared light penetrates this celestial fog effectively. Heat-detecting telescopes launched into space finally revealed our galaxy's hidden skeleton. The discovery solved astronomical mysteries that had puzzled scientists for decades. This central bar functions like a cosmic organizing system. It collects material from the galaxy's outer suburbs. Then it channels everything toward the center through the spiral arms. This process feeds ongoing star formation while providing steady fuel for our resident supermassive black hole. What if you discovered that among 100 billion neighbors, you're basically cosmic middle management? Our sun deserves some honest perspective. Our life-giving star represents the stellar equivalent of suburban middle management. Not special, not unique, not even particularly noteworthy. Astronomers classify stars into distinct categories based on mass, temperature, and brightness. Our sun falls into something called G-type main sequence. That's scientific terminology for average yellow star that burns fuel predictably. About 7% of galactic residents belong to this unremarkable category. Our sun weighs exactly 1 solar mass by definition. Astronomers literally use it as the standard unit for measuring stellar masses. It's the cosmic baseline for ordinary. Here's where our sun's mediocrity becomes strikingly apparent. Red supergiant stars scattered throughout our galaxy grow so massive they'd engulf Jupiter's entire orbit. They would completely swallow Earth, Mars, Venus, and the asteroid belt. Some grow large enough to engulf Saturn. Blue hypergent stars burn so intensely they outshine our sun by millions to one. They consume nuclear fuel rapidly and explode in spectacular supernovae. These stellar celebrities briefly outshine entire galaxies. They represent the galaxy's true cosmic superstars. Meanwhile, tiny red dwarf stars compose 75% of our stellar population. They burn fuel so efficiently they'll outlast our sun by trillions of years. Even after our galaxy collides with Andromeda, these stellar misers will still be burning steadily. Our sun's eventual death will be utterly unremarkable. In 5 billion years, it expands into a red giant briefly. Then it sheds outer layers into space, creating a pretty planetary nebula. Finally, it settles into white dwarf retirement the size of Earth. No dramatic explosion, no spectacular cosmic finale. Yet somehow this completely ordinary star created perfect conditions for life. Sometimes the most average things produce the most extraordinary results. Our cosmic middle manager turned out to be exactly what Earth needed. Picture walking into the universe's most exclusive downtown district. You've just entered our galaxy's thin disk. This cosmic penthouse stretches just 1,000 light-years thick. It's surprisingly flat considering the galaxy spans 100,000 light-years across. It's like living in a cosmic pancake where all the action happens. The thin disk operates like the ultimate gated community. Only stars younger than 10 billion years qualify for residence here. These stellar millennials burn bright blue and white. They consume fuel at rates that would bankrupt older, more conservative stars. They party hard and live fast. They burn through nuclear reserves with reckless abandon. What makes this cosmic neighborhood so special? Fresh construction materials arrive constantly from recent stellar explosions. The thin disk contains the galaxy's richest supply of heavy elements: carbon, oxygen, silicon, iron, all the cosmic ingredients needed for rocky planets. These young stars formed from gas clouds already enriched by previous generations. They're trust fund babies born with silver spoons in their cosmic mouths. Drive through this stellar suburbia and you'll witness the galaxy's most active construction zones. Massive star-forming regions stretch across hundreds of light years. New stellar residents move in every few years. The Eagle Nebula alone cranks out fresh stars like a cosmic assembly line. Hot, massive stars illuminate these nurseries with intense radiation. They sculpt surrounding gas into magnificent architectural formations. But this glamorous lifestyle comes with serious consequences. These young stellar hotshots burn through fuel faster than they can replenish it. The most massive residents weigh 20 times more than our Sun. They will explode as supernova within just 10 million years. That's barely enough time to get comfortable before going out in spectacular fireworks. Our middle-aged Sun technically qualifies for thin disk residency. At 4.6 billion years old, it's too mature for this youthful demographic. Still, it feels like it commutes from the cosmic suburbs. It watches stellar millennials live their high-energy lifestyles while maintaining a more sustainable approach. There's something comforting about a neighborhood where everyone knows their neighbors and nothing dramatic ever happens. Welcome to the galaxy's thick disk. This represents stellar middle class at its finest. The thick disk spans about 3,000 light-years in height. That's 3 times thicker than the trendy thin disk below. These are the cosmic suburbs where responsible, mature stars have settled down. They've outgrown wild youth and embraced sustainable lifestyles. The thick disk houses stars between 10 and 12 billion years old. These stellar professionals burn fuel at conservative rates. They prioritize longevity over flashy displays of energy. Think of them as the cosmic equivalent of hybrid car owners. They've traded sports cars for family sedans with excellent safety ratings. What distinguishes these suburban stellar residents? They contain fewer heavy elements than their younger neighbors below. These stars formed when the galaxy was still relatively metal poor. They represent the first wave of successful homeowners. They built solid foundations with limited resources. The thick disk operates like a well-established residential area. Mature trees line the streets. Property values remain stable. Stellar residents here maintain predictable orbits with modest eccentricities. No dramatic elliptical paths or reckless high-speed chases around the galactic center. These stars commute along reliable routes that haven't changed in billions of years. Population density runs lower than the bustling thin disk below. Stars spread out with comfortable distances between neighbors. They avoid the overcrowding and intense radiation that plague younger generations. It's like having actual backyards instead of cramped urban apartments. Our Sun does not qualify as a thick disk resident based on age and composition. However, its current orbit places it right at the boundary. It's like living in transitional neighborhoods where young professionals gradually give way to established families. Close enough to downtown for occasional visits, far enough out for peace and quiet. This stellar middle class provides the galaxy's most stable environment for planetary development. Unlike chaotic star-forming regions or sparse outer wastelands, thick disk neighborhoods offer perfect balance. They provide heavy elements, stable orbits, and reasonable radiation levels for complex chemistry. Money talks, but in our galaxy's central bulge, gravitational influence writes the entire conversation. Welcome to cosmic Manhattan. This dense, expensive downtown core spans roughly 10,000 light-years across. Only the oldest, wealthiest stellar residents can afford these astronomical property values. The bulge houses the galaxy's oldest permanent residents. These stellar aristocrats formed over 12 billion years ago. They've witnessed the entire history of galactic development, from primitive gas clouds to today's sophisticated spiral architecture. Think of them as old money families whose ancestors bought prime real estate when it was still affordable wilderness. Stellar density reaches mind-bending levels in some regions. Stars packed together 1,000,000 times denser than our solar neighborhood. If Earth orbited a bulge star, our night sky would blaze constantly. Thousands of stellar neighbors would shine bright enough to read by. The radiation environment would make complex life impossible, but the light show would be absolutely spectacular. What makes these ancient stars so wealthy? They control galactic central real estate through pure gravitational influence. Every transaction in the galactic economy eventually flows through the bulge. Supermassive black holes and dense stellar populations regulate cosmic commerce. It's like owning all the banks while also controlling the Federal Reserve. The bulge operates under completely different economic principles than suburban neighborhoods. Stars here follow chaotic, highly elliptical orbits. They swing from the galactic center out to inner disk regions. These cosmic commutes can take millions of years to complete, but gravitational rewards justify the extensive travel times. Property values have appreciated steadily for over 12 billion years. Original stellar residents who bought in early now enjoy astronomical returns. Their combined mass influences every other star's orbital patterns. They're the ultimate cosmic landlords who collect rent through gravitational interactions. But exclusive lifestyle comes with significant downsides. Intense stellar crowding creates high-stress environments. Close encounters regularly disrupt planetary systems. Any Earth-like worlds around bulge stars would have been gravitationally evicted long ago. Privacy and stability become luxury commodities in prime cosmic real estate. The bulge also houses our galaxy's central engine. The supermassive black hole weighs as much as 4 million suns. This represents the ultimate downtown landlord. It collects rent through stellar material while occasionally evicting troublesome tenants. Even the wealthiest residents must respect this cosmic authority. Isolation to civilization, and our galaxy accommodates even the most antisocial stellar personalities. Beyond busy metropolitan areas lies the galactic halo. This sparse, peaceful realm extends roughly 300,000 light-years from center. It creates a spherical envelope around entire galactic structure. It's like moving so far into the country that your nearest neighbor lives several states away. Halo residents represent the galaxy's most extreme introverts. These ancient stars formed when cosmic real estate was cheap and plentiful. They chose isolation over community. They prefer enormous distances from fellow stellar residents. Some halo stars wander so far they spend millions of years in complete cosmic solitude. The population density makes the halo feel like a stellar ghost town. While disk neighborhoods pack thousands of stars into small volumes, halo regions might contain 1 star per cubic light-year. Imagine living where your nearest neighbor resides in the next time zone. The peace and quiet would be absolute. But ordering takeout would be impossible. Most halo residents are cosmic senior citizens over 12 billion years old. These stellar hermits witnessed the galaxy's formation from primitive gas clouds. They remember when the Milky Way was just unorganized smaller groups slowly merging. They're like rural residents whose families owned property before the county was officially incorporated. Halo stars follow highly eccentric orbits that carry them on epic journeys through space. A typical resident might spend millions of years climbing outward from the galactic center. They reach maximum distance somewhere beyond the visible disk. Then they fall back inward for another million-year round trip. It's the ultimate cosmic road trip with no speed limits. Why do these stars choose such isolated lifestyles? They formed before the galaxy organized itself into neat spiral structure. Early stellar generations had to accept whatever orbital paths chaotic gravitational environments provided. Many got ejected during violent mergers when smaller fragments combined to build today's Milky Way. The chemical composition of halo residents reflects their ancient origins. These stars contain very few heavy elements. They formed before stellar explosions enriched the galactic environment with carbon and iron. They're cosmic antiques made from original universe materials, mostly hydrogen and helium with just traces of heavier elements. Halo stars occasionally venture into civilized galactic neighborhoods during orbital journeys. But they're just passing through. They don't participate in local politics or contribute to spiral wave patterns. They remain independent cosmic citizens who march to their own gravitational drums. Galactic sociology gets genuinely strange. Each floor of our cosmic apartment building doesn't just house different ages of stars. It actually produces entirely different species of stellar residents. Each species has distinct characteristics, behavior patterns, and chemical signatures. It's like discovering that apartment buildings automatically generate different types of people based on their local environment. Astronomers classify these stellar populations into 3 distinct species. Population 1 stars inhabit the thin disk and represent the galaxy's newest generation. These stellar millennials contain between 1% and 4% heavy elements by mass. That might sound tiny, but it provides enough cosmic metals to build rocky planets. They're star system developers with premium construction materials. Population 2 stars occupy the thick disk, bulge, and halo regions. These stellar boomers contain only 0.1% to 1% heavy elements. They formed when the galaxy was still chemically primitive, before stellar explosions distributed cosmic metals throughout galactic neighborhoods. Think of them as pioneers who built homesteads using mostly original universe materials. But here's where it gets really strange. There should be population 3 stars representing the galaxy's very first generation. These cosmic founding fathers would contain almost no heavy elements whatsoever. Pure hydrogen and helium with maybe trace lithium. Astronomers have searched desperately for these stellar ancestors, but they seem to have completely vanished from the galaxy. The mystery of missing population 3 stars has profound implications. These first-generation giants should have been massive enough to explode violently. They would have completely obliterated themselves in pair instability supernovae. These explosions outshine entire galaxies. No stellar remnants. No white dwarfs or neutron stars. Just spectacular fireworks that seeded the early galaxy with first heavy elements. Each stellar population follows completely different orbital patterns and life strategies. Population 1 stars stick close to the galactic plane. They participate in spiral wave compression cycles that trigger ongoing formation. Population 2 residents follow more chaotic paths. They carry them through multiple galactic neighborhoods during billion-year commutes. The chemical differences create a galactic caste system based on stellar birth timing. Late arrivals get premium building materials and prime orbital real estate. Early settlers had to make do with primitive conditions, but they gained the advantage of extreme longevity. It's cosmic proof that timing really is everything. What's most remarkable is how this structure reveals the galaxy's entire construction history. By studying stellar chemical signatures and orbital patterns, astronomers reconstruct billions of years of evolution. Each star serves as a time capsule preserving conditions from its birth era. The galaxy's residents are living historical documents that record our neighborhood's transformation from chaos into organized beauty. Galactic downtown sits the universe's most powerful crime boss. This cosmic overlord doesn't rule through violence or intimidation. It controls everything through pure gravitational authority. Every other stellar resident looks like small-time criminals compared to this cosmic godfather. Meet Sagittarius A star. The supermassive black hole weighs as much as 4 million suns combined. It has been running galactic operations for over 13 billion years. This gravitational godfather operates the ultimate protection racket. Every star in our galaxy pays tribute through orbital mechanics, whether they realize it or not. The closer you live to downtown, the faster you must move. Otherwise, gravitational forces could obliterate entire solar systems. It's like living where the local dawn can literally bend space and time. He enforces his will through pure cosmic authority. The numbers behind this cosmic authority figure are genuinely terrifying. Sagittarius A star contains 4 million solar masses crushed into a region smaller than Mercury's orbit. That creates gravitational forces so intense they warp space-time itself. Near the event horizon, gravity becomes so powerful that even light can't escape. Once it crosses that cosmic threshold, nothing returns. But here's what makes this galactic boss truly intimidating. It doesn't need to work hard to maintain control. The black hole sits quietly at the galactic center. Its gravitational influence extends outward for thousands of light years. Every star in the galaxy feels its presence. Every orbital path gets shaped by its massive influence. This cosmic crime boss has been growing its operation for billions of years. It started smaller and gradually absorbed stellar victims. Gas clouds and occasionally entire star systems wandered too close to downtown operations. Each meal makes it slightly more massive. Each victim extends its gravitational reach further into galactic suburbia. The black hole's feeding habits reveal its true nature. It operates as a cosmic vacuum cleaner with an appetite that can never be satisfied. When material spirals inward, it forms an accretion disk. This creates a cosmic conveyor belt delivering stellar snacks to the event horizon. The friction heats in falling material to millions of degrees. This creates some of the most energetic phenomena in the known universe. Our solar system maintains respectful distance from this gravitational overlord. At 26,000 light-years away, we avoid direct interference in daily orbital business. But make no mistake, even from our suburban location, we still orbit this cosmic boss once every 225 million years. We're all part of its gravitational territory. Its most powerful boss operates like a shadowy crime figure who never appears in public. Despite weighing as much as 4 million suns, Sagittarius A star remains completely invisible to ordinary telescopes. This cosmic dawn has perfected hiding in plain sight. It uses natural camouflage that makes direct observation nearly impossible. The galactic center resembles the most exclusive private club in the universe. Layers of cosmic security keep prying eyes away from the boss's operations. Massive dust clouds stretch across thousands of light years. They create an impenetrable curtain that blocks visible light from reaching suburban neighborhoods. It's like trying to photograph a crime meeting through several miles of thick fog. These cosmic dust clouds aren't just inconvenient. They represent some of the most effective natural security systems in the galaxy. Dust particles absorb and scatter visible light so efficiently that optical telescopes become essentially useless. Trying to see the galactic center with normal telescopes is like watching television through a brick wall. For centuries, astronomers played frustrated cosmic detectives. They tried gathering evidence on a suspect who never left fingerprints. They could see gravitational effects of something massive lurking downtown, but the boss himself remained completely hidden. Stars near the center moved at incredible speeds. They clearly orbited something with tremendous mass, but what exactly pulled their strings remained a cosmic mystery. The breakthrough came when astronomers learned to see through the boss's disguise. They used infrared vision to penetrate dust clouds like cosmic X-ray machines. Heat-detecting telescopes revealed the hidden architecture of the galactic center. Suddenly, investigators could observe the crime scene directly. They watched stars zip around an invisible gravitational puppet master. Even with infrared technology, the black hole itself remains completely invisible. By definition, nothing can escape from inside the event horizon, not even light or electromagnetic radiation. Astronomers can only observe the black hole's influence on its surroundings. Like cosmic forensics, experts reconstructing crime scenes by studying evidence left behind. The most dramatic evidence comes from watching stellar victims approach too close. Occasionally, a star or gas cloud wanders into the danger zone. It gets torn apart by tidal forces. These cosmic executions create spectacular fireworks. The doomed material spirals inward, heating up and glowing brilliantly, just before disappearing forever beyond the event horizon. Modern space-based telescopes have finally managed to image the immediate vicinity around Sagittarius A star. But even cutting-edge instruments can't photograph the black hole directly. They capture the glowing accretion disk and shadows cast by gravitational lensing effects. It's like photographing a crime boss by taking pictures of his shadow. The most exclusive and dangerous neighborhood of our downtown, a small group of stellar daredevils has taken on the universe's most hazardous job. These cosmic kamikaze pilots serve as personal bodyguards to our galactic crime boss. They orbit Sagittarius A star at speeds that approach the cosmic speed limit. It's like watching Formula One drivers race around a track where the slightest mistake results in complete obliteration. The most famous stellar thrill seeker is S2. This blue supergiant weighs about 14 times more than our Sun. This cosmic hotshot completes one orbit around the central black hole every 16 years. It follows an elliptical path that brings it closer to the event horizon than any other known star. At closest approach, S2 races past the black hole at 5,000 miles per second. That's roughly 2.5% the speed of light. These stellar bodyguards operate under working conditions that would terrify any reasonable star. During S2's closest approach to the boss, it experiences gravitational forces 1,000 times stronger than anything our Sun encounters. The tidal forces alone should tear a normal star apart like cosmic silly putty. Yet somehow these stellar daredevils maintain their structural integrity. They perform death-defying orbital stunts without falling apart. The S stars provide astronomers with front-row seats to the most extreme gravitational physics show. When S2 swings closest to Sagittarius A star, it becomes a living laboratory. It tests Einstein's general relativity under conditions impossible to recreate anywhere else. The star's orbit actually shifts slightly each revolution due to relativistic effects. This proves that massive objects really do warp space-time exactly as Einstein predicted. What makes these stellar bodyguards even more remarkable is their apparent loyalty. Despite obviously hazardous working conditions, they maintain their cosmic security detail. Most stars would have been gravitationally expelled from such extreme orbits long ago. The fact that multiple S-stars maintain stable paths suggests they've been performing this job for thousands of years. The recruitment process for S-star positions remains a cosmic mystery. These massive blue giants somehow ended up in the galaxy's most exclusive and dangerous neighborhood. They possibly got captured during close encounters with the central black hole. It's like discovering that the world's most dangerous bodyguard job consistently attracts the most qualified candidates through pure cosmic coincidence. Watching S-stars perform their duties provides direct evidence for the black hole's existence and mass. The speeds required to maintain these tight orbits can only be explained by something containing millions of solar masses. These stellar witnesses provide testimony that even the most skeptical cosmic jury can't ignore. The S-stars also serve as early warning systems for major changes in the boss's behavior. If Sagittarius A star suddenly started consuming large amounts of material, the S-stars would experience the effects first. They're cosmic canaries in the galaxy's most dangerous coal mine. Crime boss possesses superpowers that would make comic book villains weep with envy. Sagittarius A star doesn't just control stellar neighborhoods through conventional gravitational muscle. It literally bends the fundamental structure of reality itself. Near the black hole's territory, space stretches like cosmic taffy. Time flows like thick honey. This creates a zone where normal physics become guidelines rather than absolute rules. Einstein's general relativity predicted these reality warping effects. But the galactic center provides the ultimate testing ground for cosmic physics. When S-star bodyguards race past the black hole during closest approaches, they experience time dilation effects. Time actually flows slower in regions of intense gravity. These stellar daredevils age more slowly than their suburban counterparts. The numbers behind this temporal manipulation are genuinely mind-bending. When S2 swings closest to the black hole, it experiences gravitational time dilation. It amounts to about 200 seconds per year compared to clocks in our solar neighborhood. That might sound modest, but it represents measurable proof. Massive objects can literally slow down the passage of time. The cosmic boss operates its own temporal authority. But time manipulation is just the beginning of the black hole's reality-bending repertoire. The massive gravitational field also warps space itself. This creates what astronomers call gravitational lensing effects. Light rays passing near the black hole get bent and twisted, like laser beams passing through cosmic funhouse mirrors. This spatial distortion means looking toward the galactic center becomes like navigating through a hall of mirrors. The most extreme relativistic effects occur right at the event horizon. Here, space and time become so distorted that normal concepts break down. Before and after start to lose meaning. An outside observer watching something fall into the black hole would see it gradually slow down. It would appear to freeze at the event horizon. Meanwhile, the falling object experiences time normally as it crosses into oblivion. These reality-warping superpowers extend far beyond the immediate vicinity. The massive gravitational field influences orbital mechanics of every star within thousands of light years. Even our solar system follows an orbital path tied to the galactic center. But the wider galaxy follows the combined gravity of all its mass. The cosmic boss also demonstrates another reality-bending trick called frame dragging. The black hole's rotation literally drags spacetime along like a cosmic whirlpool. This effect means space itself rotates around the spinning black hole. This creates a zone where maintaining a stationary position becomes impossible. It's like trying to stand still while riding on a cosmic merry-go-round. Modern technology has finally allowed astronomers to measure these relativistic effects directly. They track precise orbital movements of S-star bodyguards. When S2 completed its closest approach in 2018, observers detected exact gravitational redshift and orbital precession. Einstein's equations predicted these effects over a century ago. The cosmic crime boss provided ultimate validation for humanity's understanding of reality's most fundamental rules. At the center of our galactic empire sits the ultimate cosmic dictator. Its gravitational decrees shape the destiny of the inner neighborhood. From downtown outward, Sagittarius, a star's 4 million solar mass authority, anchors the galactic center. It shapes the tightest orbits and influences the Milky Way's long-term rhythm, whether they realize it or not. This cosmic autocrat doesn't govern through committees or democratic processes. The dark matter halo shapes galactic policy through environmental control. It makes visible matter dance to gravitational music only the shadow government can hear. Every stellar orbit, every spiral arm pattern, every galaxy-wide traffic flow operates according to rules. Rules enforced by invisible cosmic bureaucrats who maintain absolute power. The scale of this shadow government operation would impress any political scientist. The dark matter halo weighs roughly 10 times more than all visible matter in our neighborhood. It extends invisible influence out to distances of 600,000 light-years from the galactic center. That's 6 times larger than the visible galaxy. This creates a cosmic shadow state that dwarfs the stellar democracy most residents think they're living in. But here's where the cosmic political situation becomes truly surreal. The dark matter shadow government apparently consists of particles that interact only through gravity. These invisible political operators can't communicate with ordinary matter through electromagnetic radiation. They remain completely immune to every transparency requirement. It's like having a government composed entirely of political ghosts. The dark matter halo's governing philosophy focuses on large-scale cosmic infrastructure management. The invisible administration maintains galactic rotation curves. It enforces spiral arm traffic patterns. It regulates overall gravitational architecture that keeps our cosmic neighborhood organized. Think of them as cosmic urban planners who work exclusively on billion-year development projects. This shadow government's influence extends far beyond our local galactic constituency. Dark matter halos apparently control gravitational politics of galaxy clusters. They manage cosmic web architecture and large-scale structure formation throughout the observable universe. We're not just living under invisible local political control. We're part of a cosmic shadow state that extends its influence across billions of light years. The most unsettling aspect of dark matter's political control is its apparent permanence. Unlike human political systems that change through elections or revolutions, gravitational government operates according to fundamental physics. The dark matter halo has been running our galactic neighborhood for over 13 billion years. It will continue its invisible administration for trillions of years into the cosmic future. Recent cosmic opinion polls suggest that dark matter's shadow government maintains approval ratings approaching 100%. This occurs primarily because ordinary matter has no choice but to follow gravitational policies. Opposition movements become physically impossible rather than merely impractical. It's the ultimate cosmic political success story. A government so effective at environmental control that resistance becomes impossible. For centuries, astronomers stared at spiral galaxies and made the most reasonable assumption possible. Those beautiful curved arms must be permanent structures made of stars, like cosmic highways paved with stellar residents. This seemed perfectly logical until scientists realized they were looking at the universe's most elaborate optical illusion. The shocking truth emerged in the 1960s when mathematicians Lin and Xu calculated something impossible. If spiral arms were solid structures rotating with the galaxy, they should wrap up like garden hoses. Our galaxy has been spinning for over 13 billion years. The spiral pattern should have wound itself into cosmic spaghetti long ago. Yet there it sits, maintaining perfect spiral architecture. The solution to this spiral puzzle turned astronomy upside down. Those magnificent arms aren't permanent structures at all. They're waves. Density waves, to be precise. They sweep through the galactic disk like cosmic traffic jams, moving at their own leisurely pace. Imagine rush hour congestion that travels around the Beltway at 20 miles per hour. Individual cars zoom through at 60 miles per hour. The traffic jam maintains its shape even though it's made of completely different vehicles every few minutes. This cosmic traffic jam operates on mind-bending scales. The density waves that create spiral arms crawl around the galaxy at roughly 30 miles per second. That's practically standing still compared to 140 miles per second orbital speeds of individual stars. As stars zip through these slow-moving density concentrations, they get temporarily bunched together, like cars backing up behind a cosmic construction zone. But here's where the illusion becomes truly spectacular. The brightest, most massive stars have such short lifespans that they never escape the spiral arms. They're born, live entire lives, and explode as supernova before leaving their birthplace. These stellar fireworks create the brilliant blue-white light that makes spiral arms visible across billions of light years. We're essentially seeing cosmic construction zones illuminated by brief lives of massive stars. Stars that never get to see the rest of the galaxy. The density wave theory solved one of astronomy's most persistent mysteries. It revealed that our galaxy operates like a cosmic magician. Those solid-looking spiral arms are ghostly patterns that exist only as temporary concentrations. The beautiful spiral structure turns out to be nothing more than an incredibly persistent traffic jam, one that's been circling the cosmic beltway for billions of years. Every 100 million years, our solar neighborhood gets a complete makeover that would make any home renovation show jealous. When stars travel through the galaxy's spiral arms, they don't just encounter traffic jams. They drive through cosmic transformation zones that can completely alter their environment and behavior. When our sun cruises through relatively quiet regions between spiral arms, it enjoys peaceful suburban driving conditions. Stellar density remains low. Radiation levels stay moderate. The local environment maintains the cosmic equivalent of tree-lined residential streets. Our solar system can maintain orderly planetary arrangement without worrying about close encounters. But every 100 million years or so, our solar neighborhood enters one of the galaxy's major spiral arms. Conditions change dramatically. Stellar density increases by factors of 10 to 100. These cosmic downtown environments feature massive blue giants dominating local real estate. These stellar celebrities pump out intense ultraviolet radiation. The radiation can strip away planetary atmospheres and sterilize nearby worlds. The spiral arm experience resembles driving through the universe's most exclusive automotive district. Every other vehicle is a cosmic Ferrari burning fuel at ridiculous rates. Massive stars in these regions consume nuclear fuel so rapidly they explode within just a few million years. The resulting shock waves trigger new star formation in nearby gas clouds. This creates stellar nurseries that continuously populate spiral arms with fresh residents. Gas clouds experience even more dramatic makeovers during their spiral arm transit. The increased density and pressure in these cosmic construction zones compress the gas. It reaches critical threshold for gravitational collapse. What enters as a cold, dark molecular cloud often emerges as a brilliant stellar nursery, populated with dozens or hundreds of newborn stars. The spiral arms also function as cosmic recycling centers. Here the galaxy processes stellar waste products. Supernova explosions scatter heavy elements throughout the local environment. They enrich gas clouds with carbon, oxygen, silicon, and iron. These stellar ashes become construction materials for the next generation. It creates a continuous cycle of cosmic renewal. Our solar system has survived multiple passages through these galactic makeover zones. Each transit represents a cosmic stress test. It could potentially disrupt planetary orbits or expose Earth to sterilizing radiation. The fact that we're still here suggests incredible luck, or our solar system has developed effective strategies for navigating these encounters. The long-term effects of spiral arm passage may have actually benefited Earth's development. Some scientists propose that increased cosmic ray bombardment during transits could trigger evolutionary bursts. It increases mutation rates in terrestrial life forms. If true, our planet's journey through cosmic traffic jams might be partially responsible for life's diversity. Our galaxy operates the universe's most sophisticated transportation network. It features major interstate highways, suburban arterials, and quiet residential streets. This cosmic urban planning system efficiently manages traffic flow for 100 billion stellar commuters. This transportation network has been directing galactic traffic for over 10 billion years. The Milky Way's transportation system centers around two primary spiral highways, the Perseus Arm and the Sagittarius Arm. These cosmic interstates stretch for thousands of light years. They maintain roughly consistent spacing as they curve around the galactic center. Think of them as the galaxy's version of major interstate highways. They handle the heaviest stellar traffic and connect all important galactic metropolitan areas. Between these primary highways runs a network of secondary spiral roads. Astronomers call them spurs or branches. Our solar system currently resides on one of these cosmic suburban streets, the Orion Spur, sometimes called the local arm. This minor spiral feature connects the Perseus and Sagittarius highways, like a well-planned suburban arterial providing convenient access to major corridors. The galaxy's urban planners designed this spiral highway system with remarkable efficiency. Gravitational physics and density wave mechanics serve as cosmic civil engineers. The major arms maintain consistent spacing of roughly 12,000 to 15,000 light-years between lanes. This provides orderly traffic flow while preventing dangerous stellar overcrowding. Each level of the galactic highway system serves distinct transportation needs. The major spiral arms function like busy commercial districts. They're filled with massive blue giant stars that burn bright and fast. These cosmic truck stops provide essential services: stellar nurseries, supernova recycling centers, and heavy element distribution. But they create hazardous driving conditions for smaller stellar vehicles. The secondary spurs offer quieter suburban commuting environments. They're perfect for middle-aged stars like our Sun. These cosmic residential areas provide stable orbital paths. They feature reasonable traffic density and minimal radiation exposure from massive stellar neighbors. It's the galactic equivalent of family-friendly neighborhoods with good schools. Between all these spiral roads lie cosmic equivalent of rural counties, vast regions of galactic countryside where stellar density drops significantly. Traffic becomes sparse. These inter-arm regions offer ultimate privacy for stellar hermits, but they lack access to the galaxy's main commercial and cultural centers. The most remarkable feature of this galactic transportation network is its self-maintaining design. The spiral pattern doesn't require cosmic construction crews or regular maintenance schedules. Density wave mechanics automatically maintain proper lane spacing and traffic flow patterns. It's like having a highway system that repairs itself through pure gravitational engineering. Real estate professionals always emphasize location, location, location. Our solar system has won the cosmic lottery by securing the most desirable address in the entire galaxy. We live in the stellar equivalent of an exclusive gated community. Positioned safely between the galaxy's major spiral highway systems where traffic remains light, property values stay stable, and neighborhoods maintain quiet residential character. Our cosmic address sits roughly halfway between the Perseus arm and the Sagittarius arm, in a peaceful suburban region astronomers call the local bubble. This stellar subdivision extends about 1,000 light-years in all directions. It creates a cosmic cul-de-sac where stellar density remains low. Dangerous neighbors stay at comfortable distances. It's like living in planned communities where homeowners associations actually keep things nice. The safety advantages of our inter-arm location become obvious when you consider alternatives. Stars living directly on major spiral highways endure constant traffic from massive stellar neighbors. They face frequent supernova explosions and radiation levels that would sterilize planetary systems. Those cosmic interstate environments are perfect for young, massive stars, but they're absolutely terrible places to raise families or develop complex life. Our suburban location provides cosmic equivalent of excellent public schools and low crime rates. The nearest massive stars remain at respectful distances. This reduces radiation exposure to levels compatible with atmospheric chemistry. Supernova explosions occur rarely enough that Earth's magnetic field can handle occasional cosmic disturbances without suffering permanent damage. The local bubble also offers outstanding cosmic infrastructure that supports planetary development. Previous generations of stellar residents enriched the local environment. They provided the right mixture of heavy elements needed for rocky planet formation. We have access to all cosmic amenities: carbon, oxygen, silicon, iron, without dealing with hazardous conditions that create these materials. Property values in our stellar neighborhood have remained remarkably stable for over 4 billion years. Unlike downtown galactic regions where sudden changes dramatically alter local conditions, our inter-arm location maintains consistent environmental standards. It's cosmic suburban planning that provides predictable, family-friendly conditions across geological timescales. Our solar system's safe orbital path also provides convenient access to galactic highway systems, without requiring permanent residence in high-traffic zones. Every 100 million years or so, our orbital journey carries us through outer edges of spiral arm regions. This gives us brief exposure to the galaxy's most active stellar neighborhoods, but these cosmic business trips are short enough to avoid serious radiation damage. The long-term forecast for our cosmic suburb looks excellent. Astronomers predict that our inter-arm location will remain stable for billions of years. It will continue providing the safe, quiet residential environment that allowed life on Earth to develop. We've essentially secured permanent residence in the galaxy's most exclusive family neighborhood. Every cosmic engineer faces the same fundamental challenge. How do you build something that lasts for billions of years without requiring maintenance? Our galaxy has solved this problem by creating the universe's most persistent architectural pattern: spiral arms that maintain their elegant curved structure for over 10 billion years, despite forces that should have destroyed them long ago. The engineering challenge behind spiral persistence seemed impossible until astronomers understood the secret. The pattern exists independently of the material that creates it. It's like maintaining a perfect traffic jam that preserves its shape, even though it's made of completely different cars every few minutes. The spiral arms represent self-sustaining waves that propagate through the galactic disk, creating temporary concentrations of stars and gas while underlying wave patterns remain stable. This cosmic engineering accomplishment puts human architecture to shame. Our most durable buildings last a few thousand years before requiring major renovation. The Great Wall of China has stood for centuries but shows obvious signs of wear. Meanwhile, our galaxy's spiral pattern has maintained structural integrity across timescales that dwarf human civilization. It's like discovering a building that automatically repairs itself and never shows signs of age. The spiral pattern's persistence depends on delicate balance of gravitational forces. Rotational mechanics and density wave physics operate like cosmic clockwork. Any significant disruption could potentially destroy this billion-year architectural project. A close encounter with another galaxy, major changes in the central black hole's mass, dramatic shifts in stellar population. Yet somehow the pattern has survived multiple cosmic catastrophes. What makes this persistence even more remarkable is that the spiral pattern actually strengthens itself through positive feedback mechanisms. The density waves that create spiral arms also trigger new star formation. This creates bright massive stars that make the arms visible. These same stars explode as supernovae, creating shock waves that reinforce original density patterns. It's self-sustaining cosmic architecture that becomes more beautiful over time. The mathematical elegance behind spiral persistence rivals any human engineering achievement. The pattern maintains its shape through differential rotation. Inner parts of the galaxy orbit faster than outer regions. This creates spiral geometry automatically, like stirring cream into coffee and watching beautiful swirl patterns emerge. But unlike coffee cream that quickly homogenizes, galactic density waves maintain coherent structure indefinitely. Modern computer simulations suggest that spiral patterns can persist for entire galaxy lifetimes, potentially 100 billion years or more. This means the beautiful spiral structure defining our cosmic neighborhood could continue operating long after our sun exhausts its fuel. Every current stellar resident will either die or evolve beyond recognition. We're witnessing architectural permanence on scales that make Egyptian pyramids look like temporary construction. The spiral pattern's extraordinary longevity raises profound questions about cosmic design. How did the universe learn to create such persistent, beautiful structures, using only gravity, rotation, and basic physics? Our galaxy represents a masterpiece of self-organizing architecture. It continues inspiring astronomers and engineers seeking to understand how simple physical laws generate complexity and beauty. Welcome to the universe's busiest delivery room. Our galaxy operates a stellar maternity ward that never closes. It never takes holidays. It maintains a birth rate that would impress any cosmic demographic statistician. Every 24 hours, our galactic neighborhood celebrates the arrival of roughly 3 brand new stellar residents. Each one is a nuclear furnace that will burn for millions to billions of years. This stellar birth rate might sound modest until you consider the scale of each delivery. Every newborn star represents successful gravitational collapse of a gas cloud. These clouds contain thousands to millions of times Earth's mass. These aren't gentle arrivals. They're cosmic events that release more energy than our sun produces in millions of years. The stellar nurseries scattered throughout our galactic neighborhood work with industrial efficiency. Giant molecular clouds serve as the galaxy's pregnancy centers. They contain enough raw materials to birth entire stellar families. The Eagle Nebula alone has been delivering new stellar residents for millions of years. It has enough gas reserves to continue the cosmic baby boom for millions more. But the galaxy's reproduction system operates with fascinating seasonal patterns. Star formation rates fluctuate based on galactic weather conditions. Spiral arm interactions and availability of cosmic construction materials affect the birth rate. During peak baby boom periods, our galaxy might deliver 10 or more new stars per day. During cosmic recessions, the birth rate can drop to just one stellar arrival per week. The delivery process itself resembles the universe's most dramatic labor experience. Gas clouds contract under their own gravity for millions of years. They gradually heat up and spin faster like cosmic figure skaters. When core temperature finally reaches 10 million degrees Celsius, nuclear fusion ignites, with the cosmic equivalent of a baby's first cry. Except this cry outshines entire solar systems. What makes our galaxy's stellar maternity ward truly remarkable is its incredible efficiency at recycling cosmic baby formula. Each stellar birth consumes raw hydrogen and helium gas while producing heavier elements. When massive stellar babies eventually die and explode as supernova, they scatter heavy elements back into space. They enrich the cosmic formula for future stellar generations. It's a family business where each generation provides better construction materials for their cosmic grandchildren. The long-term statistics for galactic reproduction look surprisingly sustainable. Our galaxy currently contains enough raw materials to continue producing new stellar residents for several billion more years. The cosmic birth rate will gradually decline as available gas supplies get consumed. But the stellar baby boom that has defined our galactic neighborhood for 13 billion years isn't ending anytime soon. Every stellar superstar began life as the cosmic equivalent of an invisible wallflower, a cold, dark gas cloud drifting through space with all the charisma of cosmic fog. The transformation from invisible gas blob to blazing nuclear celebrity represents one of the universe's most dramatic coming-of-age stories. Cosmic teenagers undergo the ultimate makeover that turns introverts into the galaxy's brightest attention seekers. Stellar adolescence starts when something disturbs a gas cloud's peaceful teenage existence. Maybe a nearby supernova explosion creates cosmic peer pressure. Perhaps a passing stellar neighborhood exerts gravitational influence. Sometimes disturbance comes from collision with other gas clouds, like cosmic teenagers meeting at summer camp and deciding to completely reinvent themselves. Once a gas cloud commits to stellar transformation, changes happen with terrifying speed. Gravity becomes the ultimate personal trainer. It forces the cloud to contract and get into shape. As gas compresses, it heats up like cosmic exercise equipment during an intense workout. The cloud spins faster as it shrinks, conserving angular momentum like a figure skater pulling in their arms. The transition from wallflower to celebrity happens when nuclear fusion ignites in the cloud's core. When temperatures reach 10 million degrees Celsius, hydrogen nuclei finally overcome electromagnetic repulsion. They fuse together to form helium. It's the cosmic equivalent of a shy teenager discovering they have an incredible singing voice. But stellar puberty comes with serious growing pains. The newborn star struggles to balance inward crush of gravity against outward pressure from nuclear fusion. Too much fusion pressure, and the stellar teenager explodes like a cosmic temper tantrum. Too little, and gravity wins the struggle. It crushes the would-be star into a failed brown dwarf. The most massive stellar teenagers undergo the most dramatic transformations. Gas clouds weighing 20 to 100 times more than our sun become cosmic rock stars. They burn blue-white and consume fuel at rates that guarantee spectacular but short careers. These stellar celebrities live fast, die young, and leave beautiful stellar corpses. They influence galactic culture for millions of years after their explosive finales. Meanwhile, smaller gas clouds transform into responsible stellar citizens like our sun. middle-class stars that burn fuel conservatively and plan for billion-year careers. These cosmic adults may not grab galactic headlines, but they provide stable, long-term energy sources that make planetary systems possible. Sometimes the most successful cosmic careers belong to stars that learned moderation during teenage transformation. The stellar coming-of-age process typically takes between 1 and 10 million years. From initial gravitational collapse to stable nuclear fusion, that's incredibly fast by cosmic standards. Like watching a human teenager complete their entire adolescent transformation in just a few hours. The universe operates on timescales that make stellar puberty look like time-lapse photography. When the galaxy's most massive stellar celebrities reach the end of their brilliant careers, they don't fade quietly into retirement. Instead, they go out in spectacular cosmic explosions that distribute their accumulated wealth to every corner of the galactic neighborhood. It's the ultimate philanthropic gesture. Dying stellar billionaires give away entire fortunes in the most dramatic estate distribution ceremony imaginable. Massive stars operate like cosmic alchemists during their brief but productive careers. They run sophisticated nuclear furnaces that transform simple hydrogen into the galaxy's most valuable construction materials. These stellar factories work in layers, like cosmic onions with different fusion processes happening at each level. The core burns hydrogen into helium. Outer layers cook helium into carbon, carbon into oxygen, and oxygen into silicon. The stellar manufacturing process reaches its climax when factories attempt to fuse silicon into iron. Iron represents the end of the road for stellar energy production. It takes more energy to fuse iron into heavier elements than the process releases. When stellar cores fill up with iron, it's like a cosmic assembly line that suddenly jams up. This creates a manufacturing crisis that threatens the entire operation. The stellar crisis escalates with terrifying speed. In less than 1 second, the iron-filled core collapses from Earth's size to roughly 12 miles across. This gravitational catastrophe creates a cosmic shock wave. It rips outward through the star at 30,000 miles per second. It blows apart outer layers in what astronomers call a core collapse supernova. It's like watching the universe's most spectacular factory explosion, one that distributes the entire inventory across thousands of light years. These stellar estate sales scatter cosmic treasures that took millions of years to manufacture. Carbon, oxygen, nitrogen, silicon, phosphorus, sulfur, calcium, iron. All heavy elements essential for rocky planets and biological chemistry get blasted into space. They enrich the galactic environment for future stellar generations. Each supernova explosion represents millions of years of cosmic manufacturing distributed in a single moment. But cosmic inheritance doesn't stop with elements produced during normal stellar operations. The incredible energies released during supernova explosions create even heavier elements through rapid neutron capture processes that can't happen anywhere else in the universe. Gold, platinum, uranium, and dozens of other elements get forged in the final seconds, then immediately scattered across the galaxy. The long-term impact of these cosmic inheritance distributions has been profound. Early stellar generations contained almost no heavy elements. They were cosmic pioneers who had to make do with pure hydrogen and helium. But billions of years of supernova philanthropy have gradually enriched the galactic environment, creating the chemically diverse universe that makes rocky planets and biological systems possible. Our solar system represents one beneficiary of countless stellar inheritance distributions. Every heavy element in Earth's crust, every iron atom in our blood, every calcium molecule in our bones originated in stellar nuclear furnaces. Stars that exploded long before our sun was born. were literally made from stellar ashes redistributed by the universe's most generous cosmic philanthropists. Every carbon atom currently residing in your body has a cosmic biography that reads like the ultimate family genealogy project. Those carbon atoms didn't originate on Earth. They weren't manufactured in any earthly laboratory. They definitely didn't arrive through biological processes. Instead, they represent ancient stellar heritage passed down through billions of years of cosmic inheritance, from nuclear furnaces that died long before our planet existed. The cosmic family tree for your body's carbon atoms begins roughly 8 to 10 billion years ago, when massive stars 3 to 4 times heavier than our Sun were burning through nuclear fuel supplies. In stellar neighborhoods scattered throughout the early galaxy, these ancestral stars operated triple alpha fusion processes in their cores. 3 helium nuclei combined under incredible temperature and pressure to form each carbon nucleus, now participating in your DNA and cellular structures. Your carbon atoms lived their early lives inside stellar cores heated to 100 million degrees Celsius, temperatures hot enough to vaporize any known material. For millions of years, these atomic ancestors helped power nuclear fusion reactions. They kept their stellar hosts shining across the galaxy. They witnessed cosmic events that dwarf any earthly experience. Stellar earthquakes that released more energy than our Sun produces in centuries. The cosmic journey from stellar interior to human biology required one of the universe's most spectacular transportation systems: supernova explosions. When your carbon atoms' stellar hosts exhausted nuclear fuel supplies, they died in cosmic fireworks. Explosions that briefly outshone entire galaxies. The explosion accelerated your atomic ancestors to thousands of miles per second. It blasted them into interstellar space, where they began billion-year journeys. These carbon atoms spent eons drifting through cosmic wilderness, occasionally getting incorporated into new gas clouds, sometimes participating in formation of other stellar systems, gradually making their way toward the region where our solar system would eventually form. They survived multiple cosmic catastrophes. They avoided getting consumed by black holes. Somehow they navigated complex gravitational currents of galactic space. When our Sun and solar system formed from a collapsing gas cloud, your carbon atoms got incorporated into rocky material that would eventually become Earth. They spent billions of years locked in planetary rocks. They participated in geological processes that shaped our world's surface. Eventually, geological recycling brought them to Earth's surface. Biological processes incorporated them into the carbon cycle. The statistical improbability of this cosmic family connection borders on the miraculous. Each carbon atom in your body survived billions of years of cosmic adventures. They avoided countless opportunities for destruction. They somehow arrived at exactly the right place and time to participate in human biology. You're literally carrying pieces of ancient stars. Stars that witnessed the galaxy's early development and participated in cosmic events that occurred before Earth existed. Modern astronomy can actually trace the likely stellar origins of different elements in your body, based on their nuclear properties and cosmic abundance patterns. Your carbon came from medium-mass stellar explosions. Your oxygen from slightly more massive stellar ancestors. Your iron from supernova events in the galaxy's most active star-forming regions. You're a walking cosmic museum containing atomic artifacts from dozens of different stellar civilizations. Just like human professionals eventually face retirement decisions, every star in our galactic neighborhood will someday exhaust its nuclear fuel. They transition into one of 3 possible cosmic retirement plans. These stellar pension options depend entirely on how much mass the star accumulated during its working career. It creates a cosmic social security system where final benefits are determined by stellar birth weight. The most common retirement plan affects roughly 97% of all stellar workers. Stars with masses between 0.1 and 8 times our Sun's weight qualify for white dwarf retirement, the cosmic equivalent of downsizing to a modest condo in Florida. These stellar retirees shed their outer layers into beautiful planetary nebulae. Then they settle into compact white dwarf cores about Earth's size, but containing roughly half the Sun's mass. It's like cosmic compression therapy that packs a stellar retirement into an object dense enough to make a teaspoon weigh as much as an elephant. White dwarf retirees enjoy incredibly long but gradually fading golden years. They start retirement glowing white-hot from leftover nuclear energy. Then they slowly cool down over trillions of years while maintaining compact dignity. These stellar senior citizens will outlast every other type of cosmic resident. They'll continue glowing faintly long after all other stars have exhausted their fuel supplies. Our Sun has already secured its white dwarf retirement plan. It will begin this cosmic downsizing process in roughly 5 billion years. Stars that accumulated between 8 and 25 solar masses during their careers qualify for neutron star retirement, the cosmic equivalent of extreme downsizing that makes white dwarf compression look modest. These stellar retirees crush themselves into objects just 12 miles across, while retaining 1.5 times the Sun's mass. The resulting density becomes so extreme that a sugar cube would weigh 100 million tons on Earth. Neutron star retirees often develop eccentric hobbies during their golden years. Many become cosmic lighthouses called pulsars. They spin hundreds of times per second while beaming radiation across the galaxy. With the precision of atomic clocks, others become magnetars with magnetic fields 1 trillion times stronger than Earth's. They create cosmic retirement activities that would terrify any reasonable stellar neighbor. The most massive stellar workers face a retirement option so extreme it challenges physics itself. Those weighing more than 25 times our Sun's mass collapse into black holes, creating cosmic retirement plans that involve disappearing from the observable universe entirely. Black hole retirees become invisible gravitational authorities. They continue influencing cosmic neighborhoods through pure space-time manipulation. Each retirement option reveals different aspects of cosmic social planning. White dwarf retirees provide stable, long-term cosmic infrastructure. Neutron star retirees become cosmic research laboratories where matter behaves according to extreme physics. Black hole retirees evolve into gravitational architects that shape large-scale structure. The diversity of stellar retirement options ensures that our galactic neighborhood will remain interesting for trillions of years. Space gets terrible press as the ultimate example of nothingness. A cosmic vacuum where absolutely nothing exists between bright stellar residents. This reputation for emptiness represents one of the universe's most successful cover-up operations. The regions between stars actually contain the galaxy's most diverse and influential population. Cosmic citizens that outnumber stellar residents by enormous margins. The so-called empty space between stars operates like the galaxy's most exclusive invisible neighborhood. It's populated by trillions of atoms, molecules, dust grains, and exotic particles. They maintain active cosmic social lives completely hidden from casual observation in every cubic centimeter of interstellar space. You'll find anywhere from 1 to 1 million individual atoms, floating around like cosmic dust bunnies in the universe's largest living room. These invisible interstellar residents don't just sit around collecting cosmic dust. They participate in some of the galaxy's most important economic and social activities. Hydrogen atoms combine to form molecular clouds that serve as stellar nurseries. Dust grains act like cosmic construction workers. They provide surfaces where simple molecules can meet and combine into complex organic compounds. Carbon monoxide, water vapor, ammonia, and even alcohol molecules drift through space, like cosmic cocktail ingredients waiting for the right stellar party. The interstellar medium operates its own sophisticated recycling program, one that puts any earthly environmental initiative to shame. When massive stars explode as supernovae, they scatter heavy elements into the cosmic neighborhood. Interstellar residents collect and redistribute these precious materials for future stellar construction projects. It's like having cosmic waste management that turns stellar garbage into premium building supplies. But the most remarkable aspect of interstellar society is its incredible diversity. Different residential districts have completely different atmospheric conditions and social demographics. Some regions remain cold and sparse, just a few atoms per cubic centimeter maintaining cosmic rural solitude. Other areas become dense molecular clouds where millions of particles crowd together, like cosmic urban centers preparing for major stellar gentrification. The temperature variations in interstellar neighborhoods would challenge any cosmic real estate agent. Molecular cloud districts maintain frigid conditions around -260 degrees Celsius, cold enough to freeze any known substance solid. Meanwhile, hot ionized regions created by nearby massive stars reach temperatures of 10,000 degrees Celsius. This creates cosmic tropical zones where atoms get so excited they lose their electrons. What makes the interstellar medium truly extraordinary is its role as the galaxy's primary communications network. Magnetic field lines thread through interstellar space like cosmic internet cables. They carry information about stellar explosions and black hole activities across thousands of light years. The invisible interstellar residents serve as cosmic social media influencers. They spread news about galactic events faster than any stellar resident could travel. In the 1970s, astronomer Vera Rubin made a discovery that should have earned her a cosmic traffic ticket. She caught the entire galaxy violating fundamental laws of orbital mechanics. When she measured how fast stars actually move in their orbits, she found speed patterns that defied every prediction. It was like discovering that cars on a racetrack's outer lanes maintain the same speeds as vehicles on the inner track. According to everything astronomers thought they knew about gravitational physics, stars in galactic outer suburbs should crawl along at modest speeds. Just like planets in our solar system, where distant Neptune takes 1 in 65 years to orbit, while speedy Mercury finishes the same trip in just 88 days. The visible matter in our galaxy's center should create exactly the same pattern. Inner stars racing around quickly, while outer residents take their cosmic time. But Rubin's observations revealed something that made no gravitational sense whatsoever. Stars throughout the galactic disk all maintain roughly the same orbital speeds, regardless of their distance from center. It's like discovering that every car in a traffic circle maintains exactly 60 miles per hour, whether they're driving on the innermost lane or the outermost edge. The physics simply don't work unless something invisible is enforcing cosmic speed limits. The numbers behind this galactic speed mystery are genuinely mind-bending. Stars near the galactic center zip around at about 220 kilometers per second. Fair enough. There's plenty of visible stellar mass downtown to justify those speeds. But stars 50,000 light-years from center also maintain speeds around 220 kilometers per second, even though there's nowhere near enough visible matter to explain their breakneck pace. This cosmic speed limit violation suggested that the galaxy contains roughly 5 times more mass than astronomers can observe. Somewhere in the cosmic neighborhood, an enormous population of invisible residents was providing additional gravitational authority. They kept outer stars moving at mysteriously high speeds while remaining completely invisible. It's like discovering that your small town actually has 5 times more residents than you can see, and they're all somehow influencing local traffic patterns. The rotation curve mystery forced astronomers to confront an uncomfortable truth about cosmic demographics. Everything they could observe represents only about 20% of the galaxy's actual population. The remaining 80% consists of matter that interacts gravitationally but refuses to emit, absorb, or reflect electromagnetic radiation. These invisible cosmic citizens were hiding in plain sight. They secretly controlled the galaxy's most fundamental traffic patterns. Different scientific teams proposed various solutions to explain the missing galactic traffic police. Maybe ordinary matter was hiding in forms too dim to detect. Brown dwarf stars, black holes, or exotic compact objects scattered throughout the neighborhood. But even optimistic estimates for hidden ordinary matter couldn't account for the enormous gravitational influence required. The rotation curve observations opened one of astronomy's most profound mysteries. They revealed that our understanding of galactic demographics was fundamentally incomplete. We'd been studying cosmic sociology while missing 80% of the actual residents. Meet the galaxy's most successful organized crime syndicate, an invisible cosmic mafia that controls 85% of our neighborhood's total influence while maintaining complete anonymity. They avoid every law enforcement technique that cosmic investigators have developed. These ghostly overlords don't just hide from observation. They interact with ordinary matter only through gravitational muscle. This makes them the ultimate cosmic crime bosses who run everything from the shadows. Dark matter operates the most sophisticated protection racket in the known universe. Every visible star, every gas cloud, every planetary system moves according to gravitational rules enforced by this invisible crime family. The dark matter bosses don't need to make threats or demonstrate power through violence. Their sheer gravitational presence shapes every orbital path and controls every aspect of galactic traffic management. The evidence for dark matter's cosmic authority comes from observing how visible matter behaves. Galaxy clusters containing thousands of individual galaxies move through space at speeds that would rip them apart, unless enormous amounts of invisible matter were providing gravitational cohesion. It's like watching entire cities held together by crime families so powerful they prevent urban sprawl through pure intimidation. But dark matter's most impressive criminal operation involves cosmic money laundering on unimaginable scales. When galaxies collide in cosmic gang wars that take hundreds of millions of years to resolve, dark matter crime families pass right through each other, like cosmic ghosts, while ordinary matter gets caught in spectacular gravitational conflicts. These invisible criminal organizations remain so removed from normal cosmic society that they walk through galactic warfare without getting involved. The cosmic mafia's recruitment policies remain one of astronomy's deepest mysteries. Dark matter particles apparently interact only through gravity and possibly weak nuclear force. This makes them immune to every interrogation technique that cosmic investigators have tried. Scientists have built underground cosmic detective agencies, particle accelerators, and deep mine detectors, hoping to catch dark matter bosses engaging in criminal activities. But these invisible crime families have avoided arrest for decades. Current estimates suggest that dark matter outweighs all visible cosmic residents by ratios approaching 5-1. This means that every star, planet, gas cloud, and space rock represents a tiny minority population, living under control of invisible criminal authorities that outnumber ordinary citizens by enormous margins. We're essentially cosmic immigrants living in neighborhoods controlled by crime families we can't see, detect, or communicate with. The dark matter crime syndicate's business model focuses on cosmic real estate development and gravitational infrastructure management. Without dark matter's invisible influence, galaxies couldn't maintain their organized spiral structures. Star formation would proceed chaotically without proper gravitational zoning regulations. The beautiful cosmic neighborhoods that make galactic life possible exist only because invisible crime bosses provide the framework. What makes dark matter's criminal empire truly unsettling is its apparent immortality and cosmic patience. These invisible crime families have been running galactic neighborhoods for over 13 billion years. They outlast every visible cosmic civilization while maintaining consistent gravitational authority. They represent the ultimate cosmic organized crime syndicate, invisible, untouchable, and permanent powers that will continue controlling galactic affairs long after every current stellar resident has died. Right now, as you read these words, you're floating inside one of the galaxy's most unlikely architectural features, a gigantic soap bubble in space that stretches 300 light-years in every direction around our solar system. This cosmic bathroom accessory isn't made from detergent and water. It's a cavity in normal interstellar medium created by stellar explosions so violent they blew away most cosmic dust and gas. The local bubble represents the aftermath of the galaxy's most spectacular neighborhood demolition project. Over the past 10 to 20 million years, more than a dozen massive stars in our cosmic vicinity completed their brief careers. They exploded as supernova, releasing energy equivalent to billions of hydrogen bombs detonating every second. These stellar fireworks created expanding shock waves that swept through our galactic neighborhood, like cosmic snow plows pushing interstellar material into dense walls. Living inside this cosmic soap bubble provides our solar system with unexpected residential advantages. The local bubble contains roughly 100 times less interstellar dust and gas than typical galactic neighborhoods. This creates exceptionally clean local space that reduces cosmic radiation exposure. It provides crystal clear views of distant astronomical objects. It's like living inside a cosmic clean room where environmental conditions remain much more pleasant than average galactic suburbs. The bubble's interior architecture resembles a cosmic cathedral with soaring empty spaces. Occasional wisps of hot, ionized gas heated to temperatures around 1 million degrees Celsius punctuate the void. But don't worry, this superheated material remains so thin that it poses no threat to planetary atmospheres. The density inside our cosmic soap bubble averages just 0.005 atoms per cubic centimeter. This makes it one of the best laboratory vacuums that natural processes have ever created. Our cosmic soap bubble isn't perfectly spherical like bathroom bubbles formed by children's toys. Stellar explosions in different directions created an irregular cavity. It extends roughly 200 light-years toward the galactic center and 600 light-years in the opposite direction. The asymmetric shape suggests that our stellar neighborhood has experienced cosmic urban renewal projects with varying intensity levels. The bubble's walls consist of dense sheets of compressed interstellar material. Cosmic bubble surfaces made from gas and dust that got swept up by expanding supernova shock waves. These walls glow faintly in radio and X-ray wavelengths. This creates cosmic soap film surfaces that astronomers can observe and map to study our local environment's structure. What makes our cosmic soap bubble particularly remarkable is its influence on local star formation activities. The shock waves that created the local bubble may have triggered gravitational collapse of nearby gas clouds. They initiated stellar births in regions that might otherwise have remained dormant. We might be living inside a cosmic neighborhood where our own residential cavity has influenced nearby stellar community development. The local bubble also provides our solar system with natural cosmic storm shelter. It protects us from some of the galaxy's harsher environmental conditions. The thin interior environment reduces exposure to cosmic rays and interstellar radiation, while surrounding dense walls help deflect high-energy particles that stream through galactic space. We're essentially living inside cosmic bubble wrap that provides modest protection from the galaxy's more hazardous neighborhoods. Imagine discovering that your entire city, county, and state government were secretly controlled by invisible political operators. They shape every policy decision while remaining completely hidden from public view. That's exactly the situation with our galaxy. It operates under absolute authority of a massive dark matter halo, a spherical shadow government that extends far beyond visible galactic boundaries and controls every aspect of cosmic politics. This invisible cosmic administration doesn't govern through committees or democratic processes. The dark matter halo shapes galactic policy through environmental control. It makes visible matter dance to gravitational music only the shadow government can hear. Every stellar orbit, every spiral arm pattern, every galaxy-wide traffic flow operates according to rules enforced by invisible cosmic bureaucrats, who maintain absolute power while avoiding all public accountability. The scale of this shadow government operation would impress any political scientist studying authoritarian regimes. The dark matter halo weighs roughly 10 times more than all visible matter in our galactic neighborhood. It extends invisible influence out to distances of 600,000 light-years from the galactic center. That's 6 times larger than the visible galaxy. This creates a cosmic shadow state that dwarfs the stellar democracy most residents think they're living in. But here's where the cosmic political situation becomes truly surreal. The dark matter shadow government apparently consists of particles that interact only through gravity. These invisible political operators can't communicate with ordinary matter through electromagnetic radiation. They remain completely immune to every transparency requirement that cosmic citizens might attempt. It's like having a government composed entirely of political ghosts who control everything while remaining forever beyond investigative journalism. The dark matter halo's governing philosophy focuses on large-scale cosmic infrastructure management. The invisible administration maintains galactic rotation curves. It enforces spiral arm traffic patterns. It regulates overall gravitational architecture that keeps our cosmic neighborhood organized. Think of them as cosmic urban planners who work exclusively on billion-year development projects, while allowing local stellar governments to handle day-to-day municipal services. This shadow government's influence extends far beyond our local galactic constituency. Dark matter halos apparently control gravitational politics of galaxy clusters. They manage cosmic web architecture and large-scale structure formation throughout the observable universe. We're not just living under invisible local political control. We're part of a cosmic shadow state that extends its influence across billions of light years. The most unsettling aspect of dark matter's political control is its apparent permanence and cosmic patience. Unlike human political systems that change through elections or revolutions, gravitational government operates according to fundamental physics. The dark matter halo has been running our galactic neighborhood for over 13 billion years. It will continue invisible administration for trillions of years into the cosmic future. Recent cosmic opinion polls suggest that dark matter's shadow government maintains approval ratings approaching 100% among visible matter constituents. This is primarily because ordinary matter has no choice but to follow gravitational policies. Opposition movements become physically impossible rather than merely impractical. It's the ultimate cosmic political success story. A government so effective at environmental control that resistance becomes impossible. Step outside on any clear night in the southern hemisphere and look up. You'll immediately spot our galaxy's most famous house guests hanging out in the cosmic backyard. Like friendly relatives who've been camping in the same spot for billions of years. The large and small Magellanic Clouds aren't actually clouds at all, despite their misleading names. They're entire galaxies, complete with billions of stellar residents. They've been orbiting our cosmic household as loyal satellite companions. These cosmic neighbors represent the ultimate example of successful interstellar diplomacy. The Large Magellanic Cloud weighs roughly 10 billion times more than our Sun, making it about 1/10 the mass of our own galaxy. Like having a cosmic cousin who's smaller than you, but still substantial enough to command respect at family gatherings. The small Magellanic Cloud tips the scales at roughly 7 billion solar masses, creating a cosmic sibling rivalry where both neighbors compete for our galaxy's gravitational attention. What makes these galactic house guests truly remarkable is their visibility to completely unaided human eyesight. From southern hemisphere locations, both Magellanic Clouds appear as fuzzy patches of light, roughly 20 times larger than a full moon. Ancient navigators used them as cosmic landmarks for ocean voyages, never realizing they were looking at entire stellar civilizations. Located 160,000 to 200,000 light-years from our galactic neighborhood, the Magellanic Clouds operate like cosmic vacation resorts that showcase stellar attractions our own galaxy can't provide. The Large Magellanic Cloud hosts the Tarantula Nebula, a stellar nursery so active and energetic it would outshine Venus if located at the same distance as the Orion Nebula. This cosmic maternity ward cranks out massive stars at rates that make our galaxy's star-forming regions look sleepy. But these friendly cosmic neighbors aren't just hanging around for social visits. They're actively participating in galactic cultural exchange programs that benefit everyone involved. The gravitational interactions between our galaxy and the Magellanic Clouds create cosmic bridges of gas and stars, called the Magellanic Stream, a 600,000 light-year long trail of stellar material that connects our neighborhoods. Like the ultimate cosmic friendship bracelet, the relationship between our galaxy and its Magellanic companions resembles a cosmic mentorship program. The larger galactic household gradually influences the development of smaller neighboring communities. Our galaxy's massive gravitational influence has been reshaping the Magellanic Cloud's internal structure for billions of years, triggering enhanced star formation rates and creating spectacular cosmic fireworks that illuminate both neighborhoods. Recent astronomical observations suggest that the Magellanic Clouds may actually be cosmic newcomers to our galactic neighborhood, possibly making their first approach to our stellar community within the past few billion years. If true, we're witnessing early stages of a cosmic relationship, one that could develop into permanent family membership or eventual gravitational adoption. Our galaxy operates like the ultimate cosmic patriarch presiding over an enormous extended family. It includes more than 50 confirmed satellite galaxies, each one a complete stellar community with its own distinct personality, orbital habits, and family history. This galactic household management system puts any earthly family reunion to shame. It coordinates gravitational needs and orbital schedules of dozens of smaller galactic relatives spread across millions of light years. The satellite galaxy census reads like a cosmic phone book filled with exotic family names. Sculptor, Fornax, Leo I, Leo II, Carina, Sextans. Each name represents an entire galactic community with millions to billions of stellar residents. They follow their own internal cultural development while remaining gravitationally loyal to our central galactic authority. It's like having cousins scattered across multiple continents. They maintain local traditions but still show up for major family celebrations. These cosmic family members come in dramatically different sizes and personality types. The household ranges from tiny dwarf spheroidal galaxies weighing just a few million solar masses, to substantial satellite communities like the Magellanic Clouds that contain billions of stellar residents. The smallest family members contain so few stars they barely qualify as independent galactic entities. They resemble cosmic villages with populations smaller than individual star clusters. The family dynamics within our satellite galaxy system reveal fascinating patterns of cosmic sociology. Many satellite galaxies maintain highly elliptical orbits that carry them on epic family visits. They swing close to our galactic center for intimate gravitational encounters. Then they head back out to cosmic countryside for millions of years of peaceful suburban living. These orbital patterns create extended family relationships. Some relatives visit frequently, while others maintain more distant connections. Recent astronomical family tree research has revealed that our satellite galaxy system may consist of multiple cosmic adoption programs. Some satellite galaxies appear to be original family members that formed in our gravitational neighborhood billions of years ago. Others show signs of being cosmic immigrants that were gravitationally captured when they wandered too close. It happened during travels through intergalactic space. The satellite galaxy family structure also demonstrates remarkable cosmic diversity in stellar demographics. Some family members contain ancient stellar populations that formed when the universe was still young. Others host active star-forming regions that continue producing new stellar residents. They use materials enriched by billions of years of evolution. It's like having family members who represent every generation from great-grandparents to newborn babies. What makes our satellite galaxy family system truly extraordinary is its gravitational stability across cosmological timescales. These cosmic family relationships have been maintained for billions of years, despite complex gravitational influences of nearby galactic communities and occasional disruption from intergalactic visitors. Our galaxy has successfully managed its extended family household for longer than rocky planets have existed. Welcome to the galaxy's most sophisticated tribute system. Our cosmic household operates like a gravitational godfather, extracting regular payments from smaller satellite galaxy family members. They want to maintain independence while enjoying protection of our massive gravitational influence. This isn't a gentle family arrangement. It's a cosmic protection racket where smaller galaxies literally pay rent using their own stellar residents as currency. The tribute collection process operates through tidal forces that would make any earthly loan shark weep with admiration. When satellite galaxies approach our galactic center during orbital visits, they experience differential gravitational pull, stronger on their near side than their far side. This gravitational gradient acts like cosmic hands that gradually stretch and distort the visiting galaxy. pulling away outer stellar regions and redistributing cosmic wealth. The Sagittarius dwarf galaxy provides the most dramatic example of cosmic tribute extraction currently operating in our neighborhood. This unfortunate satellite community has been making regular tribute payments to our galactic godfather for billions of years, gradually losing stellar residents and gas reserves during each orbital approach. Astronomical forensics experts can trace long streams of stellar tribute flowing from Sagittarius directly into our galaxy's outer regions. But here's where the cosmic protection racket becomes genuinely sophisticated. The tribute system operates on automatic pilot without requiring direct enforcement from galactic crime bosses. Physics handles all collection logistics through purely gravitational mechanisms. They extract tribute payments whether satellite galaxies want to cooperate or not. It's like having a cosmic tax system that collects payments directly from bank accounts without requiring paperwork. The tribute collection rates vary dramatically based on each satellite galaxy's orbital characteristics. Satellite galaxies that maintain safe distances and circular orbits can minimize their tribute payments. They preserve most of their stellar populations while still enjoying galactic neighborhood protection. But communities that venture too close face tribute demands that can strip away significant portions of stellar residents during single encounters. Some cosmic family members have developed sophisticated tribute avoidance strategies. They allow them to maintain independent galactic status while minimizing their gravitational tax burden. The Magellanic Clouds follow orbital paths that provide regular tribute payments without threatening their core stellar populations or internal governance systems. They've essentially negotiated favorable tribute terms. The long-term implications of our cosmic tribute system reveal both benefits and costs of gravitational protection services. Satellite galaxies that pay regular tribute enjoy access to our galactic neighborhood's enhanced cosmic security, protection from intergalactic raiders, and opportunities for cultural exchange with our extensive stellar population. But communities that fall behind on payments risk eventual gravitational foreclosure. Scattered across our cosmic neighborhood lie the saddest astronomical evidence of gravitational violence. Long, thin streams of stars stretch for hundreds of thousands of light years, like cosmic crime scene tape marking locations where entire galaxies met their tragic ends. These stellar streams represent the ultimate galactic murder mysteries. Astronomical forensics experts can reconstruct final moments of satellite galaxies that were literally torn apart. The most dramatic cosmic crime scene currently visible bears the official designation Sagittarius Stream. Astronomers recognize it as the ongoing murder of an entire galactic community. It's been playing out in slow motion for hundreds of millions of years. The Sagittarius dwarf galaxy is being systematically dismembered by our galaxy's tidal forces. It leaves behind a stellar trail that wraps around our entire galactic structure. Like cosmic yellow tape marking an active crime scene, these stellar streams operate like cosmic DNA evidence that reveals exactly how gravitational murders unfold. When a satellite galaxy ventures too close to our galactic center, tidal forces begin pulling away outer stellar residents. They create leading and trailing streams of stars that follow the victim galaxy's orbital path. It's like watching a cosmic car accident in extreme slow motion. Individual stellar residents get ejected from home communities and scattered across hundreds of thousands of light years. The forensic evidence preserved in stellar streams provides astronomers with detailed cosmicopsy reports. They reveal each victim galaxy's internal structure, chemical composition, and orbital history, By studying distribution and properties of stars in these cosmic crime scenes, investigators can reconstruct the mass and size of galaxies, destroyed millions of years before human civilization developed technology to observe astronomical evidence. But stellar streams represent more than just cosmic tragedy. They're also evidence of our galaxy's ongoing urban renewal projects. They gradually incorporate stellar refugees into our own galactic community. The stars scattered by tidal disruption don't simply disappear. They become permanent residents of our galactic neighborhood, adding their chemical contributions and gravitational influence to our overall stellar population. Some of the most spectacular stellar streams in our cosmic neighborhood tell stories of galactic murders that occurred billions of years ago, when our galaxy was still young and actively expanding its gravitational territory through aggressive acquisition. The Helmy stream preserves evidence of a satellite galaxy that was torn apart over 5 billion years ago. Yet its stellar remains still follow coherent orbital paths that allow astronomers to study ancient cosmic violence. The discovery and mapping of stellar streams has revolutionized our understanding of galactic growth patterns. Rather than peaceful cosmic evolution through gradual gravitational attraction, these crime scenes reveal systematic acquisition and dismemberment of smaller galactic communities. We're living in a cosmic neighborhood built on stellar remains of dozens of victim galaxies. What makes stellar streams particularly haunting is their incredible persistence as cosmic memorials. These stellar trails can remain visible for billions of years, creating permanent monuments to satellite galaxies that once maintained independent stellar civilizations. Every stellar stream represents an entire galactic community that will never again experience autonomous governance or independent stellar evolution. Our galactic neighborhood operates under a delicate balance that resembles the ultimate Cold War between two massive stellar superpowers. They're locked in gravitational stalemate while maintaining control over dozens of smaller satellite communities. The local group contains roughly 80 confirmed galactic members, but real political power rests entirely with two dominant players: our own Milky Way galaxy and the Andromeda galaxy, located 2.5 million light-years away. This cosmic two-party system has been maintaining relative peace for billions of years, through sophisticated balance of gravitational deterrence that keeps both superpowers from attempting hostile takeovers. The Milky Way controls roughly more than 50 satellite galaxies in our immediate cosmic sphere of influence, while Andromeda maintains its own collection of galactic client states. It's like having two cosmic empires that share the same galactic neighborhood while carefully avoiding direct confrontation. The power balance between these galactic superpowers reveals fascinating asymmetries in cosmic politics. Andromeda outweighs our galaxy by roughly 2-to-1 in total mass, making it the clear heavyweight champion of local group politics. But our galaxy compensates for smaller size through superior satellite galaxy management. We maintain more diverse and active relationships with our extended family of cosmic client states. The Cold War dynamics between galactic superpowers play out through proxy conflicts among satellite galaxy populations. Smaller galactic communities sometimes switch allegiance between the major power blocks. Recent astronomical intelligence suggests that some satellite galaxies previously associated with Andromeda's sphere have been gravitationally captured by our galaxy's expanding territorial claims. These cosmic defections create ongoing tensions that could potentially escalate. But the most significant aspect of local group politics involves long-term strategic planning. Both superpowers know that inevitable cosmic confrontation is coming, Current astronomical projections indicate that our galaxy and Andromeda are approaching each other at roughly 250,000 miles per hour, setting up a direct collision scheduled to occur in approximately 4.5 billion years. This cosmic doomsday clock creates urgency in current galactic diplomacy. The approaching galactic collision has already begun influencing local group political calculations. Satellite galaxy populations must decide whether to maintain current allegiances or position themselves for survival. Some satellite galaxies may benefit from the merger by gaining access to expanded gravitational territories. Others risk being destroyed in cosmic crossfire between clashing superpowers. Preliminary cosmic war game simulations suggest that the Milky Way-Andromeda collision will result in negotiated merger rather than mutual destruction, creating a single massive elliptical galaxy that astronomers have already nicknamed Milkomeda. This ultimate cosmic peace treaty would combine both superpowers' satellite galaxy populations into a single extended family household managed by merged galactic authority. The long-term implications of this approaching galactic merger raise profound questions about cosmic citizenship. Will satellite galaxies maintain their current cultural identities under the new cosmic order? Can smaller galactic communities preserve independence during transition from Cold War competition to unified cosmic administration? The answers will determine whether local group politics evolves toward galactic federation or cosmic empire. Long before our galaxy became the organized stellar metropolis we know today, the universe resembled a cosmic construction site. Invisible architects were laying the foundation for the largest building project in galactic history. Roughly 13 billion years ago, mysterious dark matter began weaving itself into vast cosmic spider webs. They would serve as scaffolding for every galaxy, star cluster, and cosmic neighborhood that would eventually populate our universe. Picture the early universe as the ultimate cosmic real estate development. Invisible urban planners were designing the layout for future galactic cities using materials that ordinary matter couldn't even detect. Dark matter filaments stretched across millions of light years. They created a cosmic highway system. It would eventually channel ordinary hydrogen and helium gas into regions destined to become galactic downtown districts. It was urban planning on scales that make human city development look like sandbox construction projects. The cosmic architects worked with remarkable efficiency and foresight. Dark matter doesn't interact with ordinary matter except through gravity. That makes it the perfect invisible infrastructure that could organize cosmic development without interfering with the actual construction materials, like cosmic civil engineers building invisible bridges and tunnels. Dark matter created gravitational frameworks that would guide galactic formation for billions of years. Our galaxy's origin story began when ordinary matter finally started paying attention to invisible architectural plans. Dark matter had been drafting these plans for hundreds of millions of years. Hydrogen and helium gas began flowing along dark matter highways, like cosmic traffic following invisible road signs toward predetermined galactic construction zones. The gas accumulated in gravitational valleys created by dark matter concentrations. But the early galactic construction process resembled cosmic urban renewal more than organized development. Instead of a single massive construction project, our galaxy assembled itself through smaller cosmic mergers. Individual gas clouds and proto-galactic fragments gradually combined into increasingly larger stellar communities. It was like watching a cosmic city grow through neighborhood annexation rather than centralized planning. The first stellar residents to move into our developing galactic neighborhood were cosmic pioneers. they had to make do with extremely primitive building materials. These population 3 stars contained almost no heavy elements, just hydrogen and helium left over from the Big Bang. They were cosmic homesteaders who built stellar homesteads using nothing but the universe's original construction supplies. These stellar pioneers lived fast and died dramatically. They exploded as the universe's first supernovae and finally delivered heavy elements that future galactic development would require: carbon, oxygen, silicon, iron. And dozens of other cosmic construction materials got scattered throughout our developing neighborhood, creating the chemically enriched environment that would support more sophisticated stellar architecture. The cosmic construction timeline reveals incredible patience required for large-scale cosmic development projects. What started as invisible dark matter scaffolding gradually evolved into organized stellar communities. Our galaxy has been under continuous development for over 13 billion years. That makes it one of the universe's longest-running urban renewal projects. For over 10 billion years, the Milky Way has been operating the universe's most successful hostile takeover operation. Our galaxy's growth strategy reads like the business plan of a cosmic corporate raider. It built an empire through systematic acquisition and consumption of smaller galactic competitors, gradually expanding gravitational territory by identifying vulnerable satellite galaxies, slowly surrounding them with overwhelming gravitational force. The cosmic merger and acquisition process operates with ruthless efficiency of any successful predatory business strategy. Our galaxy identifies potential acquisition targets based on orbital patterns and gravitational vulnerability. Smaller satellite galaxies that venture too close to our gravitational sphere face inevitable corporate absorption, whether they want to merge with our galactic conglomerate or maintain independence as smaller cosmic businesses. The most dramatic corporate takeover currently playing out involves systematic dismemberment of the Sagittarius dwarf galaxy. This smaller galactic community made the fatal mistake of accepting our gravitational hospitality several billion years ago. What started as friendly diplomatic relations has evolved into complete corporate absorption. Our galaxy gradually strips away Sagittarius's stellar assets and incorporates them into our own galactic payroll system. But our galaxy's corporate history includes dozens of successful acquisitions. They contributed essential components to our current galactic infrastructure. The stellar halo that surrounds our galactic disk consists largely of stars inherited from previous corporate mergers, creating a cosmic employee roster that includes stellar workers originally hired by smaller galactic companies that no longer exist as independent cosmic entities. Archaeological evidence of our galaxy's corporate expansion survives in chemical signatures and orbital patterns of stars. Stellar forensics experts can identify which stars originated in our galaxy's original corporate structure, versus which employees joined our payroll through acquisition of smaller galactic competitors. Some stellar neighborhoods contain entire populations of cosmic workers who maintain distinct cultural identities, reflecting their origins in now extinct galactic civilizations. The cosmic acquisition timeline reveals our galaxy's evolution from startup cosmic business to dominant galactic corporation. Early mergers involved smaller galactic entities that contributed essential heavy elements and stellar infrastructure. More recent acquisitions have focused on satellite galaxies that provide ongoing stellar resources, while serving as cosmic subsidiaries that operate under our galactic corporate authority. What makes our galaxy's corporate expansion strategy particularly sophisticated is its long-term approach to cosmic human resources management. Rather than simply consuming acquired stellar populations, our galactic corporation has developed integration policies. They allow absorbed cosmic workers to maintain productive careers while contributing to overall galactic productivity. Former satellite galaxy employees often receive promotions to important positions in spiral arm management. The business model behind our galaxy's cosmic expansion reveals fundamental economics of gravitational corporate growth. Successful galactic corporations expand market share by acquiring smaller competitors. They absorb their best stellar talent and incorporate cosmic infrastructure into larger, more efficient galactic operations. Our galaxy represents one of the most successful examples of cosmic corporate development in the observable universe. Mark your cosmic calendars for the ultimate celestial appointment that nobody can reschedule, cancel, or avoid. In approximately 4.5 billion years, our galaxy will experience the most dramatic event in its 13 billion-year history. A head-on collision with the Andromeda Galaxy that will fundamentally reshape both stellar civilizations beyond recognition. The cosmic collision course has already been locked in through gravitational momentum. This makes the approaching galactic train wreck as inevitable as sunrise. Andromeda approaches our neighborhood at roughly 250,000 miles per hour, fast enough to circle Earth's equator in just over 6 minutes. Our galaxy hurtles toward the same cosmic intersection point with equal determination. It's like watching two massive freight trains approaching the same railroad crossing from opposite directions. Except these cosmic locomotives weigh trillions of times more than our sun. Current astronomical traffic control projections suggest that galactic collision will unfold as cosmic slow-motion disaster. It will take several billion years to complete from first contact to final merger. The initial approach phase will begin roughly 1 billion years before direct collision. That is when both galaxies' gravitational influences start seriously disrupting each other's internal traffic patterns. It's cosmic urban planning chaos that will gradually escalate. But here's the most remarkable aspect of this approaching cosmic catastrophe. Despite involving violent collision of two entire galaxies, the actual probability of individual stellar residents experiencing direct crashes remains virtually zero. Stars maintain such enormous distances between neighbors that galactic collision resembles two cosmic swarms of fireflies, passing through each other rather than solid objects smashing together. The gravitational choreography of galactic collision follows surprisingly predictable patterns. Cosmic traffic engineers can simulate these using sophisticated computer models. The initial encounter will stretch both galaxies into spectacular tidal tales, long streams of stars that get pulled away from original galactic communities, like cosmic silly putty being stretched by competing gravitational forces. The merger timeline reveals multiple collision phases that will fundamentally restructure both galactic civilizations. The first close approach will create massive stellar displacement and trigger enhanced star formation rates. Both galaxies will then separate briefly before gravitational attraction pulls them back together. For a second, more catastrophic encounter that begins the final merger process. The central supermassive black holes anchoring both galactic downtown districts will eventually spiral toward each other. In the ultimate cosmic dance of gravitational titans, when these 4 million solar mass cosmic crime bosses finally merge, they'll create gravitational wave ripples that propagate across the universe while forming a single, even more massive galactic authority. Long-term residential planning for approaching galactic collision suggests that our solar system has excellent survival prospects. Our suburban location in galactic outskirts provides natural protection from most violent central merger activities, It may also offer front-row seats to the most spectacular cosmic construction project, one that local galactic group residents will ever witness. Welcome to the cosmic retirement community that our galactic neighborhood will eventually become. A massive elliptical galaxy that astronomers have already nicknamed Milky Way. This represents the ultimate senior living facility where combined stellar populations of two ancient galactic civilizations will spend their golden years together in peaceful cosmic suburbia. This merged galactic household will operate according to completely different architectural principles than the spiral galaxy neighborhoods we currently call home. Milky Way will organize itself as a smooth elliptical galaxy without dynamic spiral traffic patterns. Instead of organized highway systems channeling stellar traffic along predictable spiral paths, the merged galaxy will feature more relaxed orbital arrangements. Stellar residents will follow gentle, randomized paths through cosmic suburbia designed for comfort rather than efficiency. The residential demographics of Galaxy Milky Way will reflect advanced age and maturity of its combined stellar populations. Most massive blue giant stars that currently illuminate our galactic spiral arms will have completed their brief careers. They'll have died spectacular deaths long before the merger occurs. The surviving stellar population will consist primarily of stable, long-lived red dwarf stars and middle-aged stellar citizens like our Sun, assuming it hasn't already evolved into white dwarf retirement. The cosmic real estate market in post-merger Milky Way will offer dramatically expanded housing options. The merged galaxy will contain roughly 1 trillion stellar residents spread across a much larger cosmic footprint, creating suburban sprawl that extends far beyond current boundaries of either original galactic community. It's like having two cities merge into a single metropolitan area with significantly improved housing availability. But the long-term forecast for Galaxy Milky Way reveals both benefits and challenges of cosmic senior community living. The merged galactic household will enjoy enhanced gravitational stability and reduced risk of external galactic threats. This creates a peaceful environment perfect for elderly stellar civilizations. However, the galaxy's star formation rate will gradually decline as available gas reserves get consumed, leading to reduced birth rates and increasingly aging stellar population. The ultimate cosmic retirement timeline for Milky Way extends far beyond normal galactic life expectancy projections. Red dwarf stars will continue providing stellar neighborhood services for trillions of years, long after more massive stellar residents have completed their careers. These cosmic senior citizens will maintain galactic civilization across timescales that dwarf the current age of the universe. The final chapter in our galactic neighborhood's cosmic biography will unfold across timescales so vast they challenge human comprehension. Eventually, even the most long-lived red dwarf residents will exhaust nuclear fuel supplies. They'll fade into white dwarf retirement, leaving Milky Way as a cosmic ghost town, populated entirely by stellar corpses, black holes, and exotic remnants. Yet even this cosmic twilight doesn't represent the absolute end of our galactic story. The merged galaxy will continue existing as a gravitational community for virtually infinite timescales. Stellar remnants will maintain orbital relationships while slowly spiraling inward due to gravitational wave radiation. Milky Way will persist as cosmic memorial to 13 billion years of galactic evolution, preserving architectural legacy of two stellar civilizations that learned to merge their cosmic households into a single, magnificent galactic retirement community.